Welcome to the Psychology and Physical Training channel. Introduction to Hypothesis. Ever wondered how crucial a hypothesis is in the world of research? In the realm of scientific inquiry, a hypothesis is our guiding light. It's our starting point, a tentative explanation for a phenomenon or a set of observations. But it's not just any explanation. A hypothesis is a proposed explanation that can be rigorously tested and scrutinized. Imagine you're a detective and you're trying to solve a case. The hypothesis is your initial hunch, your educated guess about what might have happened. But you don't just stop there. You take that hunch and you put it to the test. You gather evidence, you interview suspects, and you see if everything aligns with your initial thought. That's what researchers do with their hypotheses. They propose them based on observations or insights, and then they design experiments or studies to test these ideas. A hypothesis can be as simple as eating an apple a day will keep the doctor away, or as complex as the expansion rate of the universe is accelerating. What matters is that it's testable. A hypothesis is not just a guess, it's an informed prediction that provides a clear direction for research. It's an assertion that we can either support or refute through our investigation. If the evidence supports the hypothesis, it may become part of a broader theory. If it doesn't, well, back to the drawing board. Hypotheses are the building blocks of scientific knowledge. They drive our curiosity, our desire to understand the world around us. They lead us down new paths of discovery and innovation. They help us make sense of the complex, often bewildering world we inhabit. Without a hypothesis, research would be a random, aimless process. It would be like trying to put together a jigsaw puzzle without knowing what the picture is supposed to look like. That's why the formulation of a hypothesis is such a critical step in the scientific method. Without a hypothesis, a study is like a ship without a compass, aimlessly wandering in the vast sea of data. So let's delve deeper and explore the fascinating world of hypotheses. Formulating a hypothesis. So, how does one go about formulating a hypothesis? Well, the journey towards crafting a great hypothesis often starts with a question. This question can stem from simple curiosity, an observed pattern, or a specific problem that needs a solution. It's like a spark that ignites the flame of inquiry, but you don't just leap from question to hypothesis. There's a crucial step in between: background research. Delving into existing knowledge on the topic helps us understand what has already been discovered and what gaps remain. This is where we comb through scientific literature, journals, and studies, immersing ourselves in the subject matter. It's like gathering ingredients before starting to cook a meal. After this comes the actual formulation of the hypothesis. This is where we take our initial question, armed with the insights gained from our background research, and forge it into a clear, concise, and testable hypothesis. But what does it mean for a hypothesis to be testable? It means that it must be possible to prove it either true or false using the methods of science. A hypothesis that cannot be tested is like a riddle with no answer. It may be intriguing, but it doesn't advance our understanding. Also, a hypothesis is not a wild guess. It's an educated prediction based on what we already know. It's like a detective making an informed guess about who the culprit might be based on the evidence gathered so far. Remember, a hypothesis doesn't have to be correct. It just has to be testable. Even a hypothesis that turns out to be false can still be useful, as it helps us refine our understanding and guides future research. To sum up, formulating a hypothesis is a process that starts with a question, requires thorough background research, and culminates in a testable prediction. It's a critical part of the scientific method and forms the foundation of any research study. A well-formulated hypothesis is like a roadmap, guiding researchers towards their destination. Methods of stating hypothesis. Now that we have a hypothesis, how do we state it? Well, there are several methods to do this, but the most common ones are through null and alternative hypotheses. The null hypothesis is like the skeptic in a debate. It asserts that there's no relationship or effect between the variables you're studying. It's the status quo, the assertion that any change you observe is merely due to chance. On the flip side, we have the alternative hypothesis. This is the hopeful rebel, the claim that there is indeed an effect or relationship. It's the antithesis of the null hypothesis, suggesting that the change you're seeing is not due to chance, but is a real measurable phenomenon. Stating hypotheses may seem like a simple task, but it requires a clear understanding of your research and what you're trying to achieve. Remember, Stating your hypothesis clearly and concisely paves the way for a smooth research journey. Theories versus hypothesis. Are theories and hypotheses the same thing? Now, that's a question that often sparks confusion. So let's clear that up, shall we? Hypotheses and theories, while both crucial components of the scientific method, are not interchangeable terms. A hypothesis is a proposed explanation for a specific set of observations. A preliminary answer to a question, if you will. It's a starting point that can be tested, challenged, and potentially disproven. On the other hand, a theory is a well-substantiated explanation of some aspect of the natural world. It's an interpretation that has been repeatedly tested and refined over time, withstanding rigorous scrutiny and accumulating a significant body of evidence. In essence, a theory is a mature hypothesis that has survived waves of testing and still stands strong. So, to put it simply, while hypotheses are the seeds of knowledge, theories are the trees that grow from those seeds. Types of hypothesis. Did you know there's more than one type of hypothesis? Indeed, depending on the nature of the study, researchers might use different types of hypotheses. Let's explore some of them. First up, we have the simple hypothesis. As its name suggests, it's straightforward and focuses on a single variable. For instance, a simple hypothesis might propose that consuming more fruits leads to increased overall health. But what if a researcher wants to investigate the relationship between multiple variables? That's where the complex hypothesis comes in. For example, a complex hypothesis might explore how both fruit and vegetable consumption impacts overall health. Next, we have the directional hypothesis. This type of hypothesis predicts the direction of the expected relationship between variables. Imagine a researcher who hypothesizes that higher levels of physical activity will decrease the risk of heart disease. This is a directional hypothesis because it anticipates a specific direction, an increase in one variable leading to a decrease in the other. In contrast, a non-directional hypothesis doesn't predict the direction of the relationship. It merely suggests that a relationship exists, but it doesn't specify whether an increase in one variable will lead to an increase or decrease in the other. So, if our researchers simply hypothesized that physical activity levels impact heart disease risk without specifying how, they're working with a non-directional hypothesis. Each type of hypothesis serves a different purpose and is used under different circumstances. Simple and complex hypotheses are great for exploring relationships between variables, while directional and non-directional hypotheses are useful when you're not sure what to expect or want to keep your predictions open-ended. Remember, the type of hypothesis you choose can shape the direction and outcome of your research. So choose wisely and take your time to formulate it accurately. Understanding the type of hypothesis to use can significantly enhance the quality of your research. So whether you're a seasoned researcher or just starting out, being aware of these different types of hypotheses can be a game changer. Characteristics of a good hypothesis. What makes a good hypothesis? That's the question we're going to explore in this scene. The answer is not as simple as you might think. A good hypothesis is not just any guess or prediction. It's a well-thought-out proposition that serves as a starting point for further investigation. First and foremost, a good hypothesis must be testable. It's not enough to have an idea or a hunch. A hypothesis needs to be something you can put to the test using scientific methods. This means it should be based on existing knowledge and should be designed in a way that allows for the collection of measurable, observable data. Next, a good hypothesis needs to be simple. Albert Einstein once said, "If you can't explain it simply, you don't understand it well enough." The same holds true for a hypothesis. It should be straightforward and devoid of unnecessary complexity. The simpler the hypothesis, the easier it is to test and the clearer the results will be. Clarity is another crucial characteristic of a good hypothesis. It should be clear and precise, leaving no room for ambiguity. Every term you use in your hypothesis should be clearly defined, ensuring that anyone who reads it will understand exactly what you mean. This clarity helps to avoid misunderstandings and misinterpretations, which can lead to inaccurate results or conclusions. Finally, a good hypothesis should be relevant. It should address a meaningful question or problem, and its results should have the potential to add to our understanding of the world. A hypothesis that doesn't lead to new insights or knowledge is like a road that doesn't lead anywhere. It's not very useful. So there you have it. The characteristics of a good hypothesis. It needs to be testable, simple, clear, and relevant. Remember, a hypothesis is not just a wild guess. It's an educated prediction based on what we already know, and it serves as a stepping stone to new discoveries. A good hypothesis is not just a guess, it's an educated prediction that opens up a world of discovery. And if you like this video, do not forget to subscribe and follow to the Psychology and Physical Training channel for more videos. Thanks for watching.